Hello, in this video I'd like to introduce composition animations.
I'm Darren May, President and co-founder of Crank211. I'm also a Microsoft MVP for Windows development. At Crank211 we design and deliver universal Windows applications, web applications, cross-platform mobile, and we also create and deliver training courses. You can find me on Twitter at Darren May and on the web at www.crank211.com.
So why would we want to use composition animations? Well, a key reason is performance. When we're building universal Windows applications, our UI is running on a single thread. That is obviously a limiting factor when it comes to doing a large number of updates, plus performing another number of other operations. We don't want our UI and specifically our animations and glossy effects to be constrained by what we're doing within our application itself. That's the great thing about the system compositor. We can delegate to the compositor, which runs at 60 frames per second, the execution of these animations and effects, which frees up our application to be as smooth as possible. That opens up a lot of opportunities for us to create very fluid effects in our applications and make them very attractive and engaging for the users. Another nice thing about composition animations is the fact that you create templates. The idea behind that is that a specific animation can be templated and reused across a number of objects where perhaps you might want to tweak a property of that template, but it allows us a lot of reuse, which is very efficient. Of course, this is a very high-level overview of composition animations. If you want to dive deeper, by all means go out and visit the Microsoft documentation. So what sort of things can we animate? Well, if you've looked at my previous video where I talked about visuals, you'll know that there are a number of properties on those visuals, such as offset, opacity, rotation, and so on. You could animate all of those, so that obviously gives us the opportunity to create some very interesting effects where we might move images around, fade them in and fade them out, spin them around when we interact with them, and so on. We can also animate what's called an inset clip. Now, an inset clip is kind of an offset from the exterior of an object so that we can clip into the center. So we've got a little animation here that demonstrates that. So if this is our object, if we animated all of the clips, the left, the right, the top, and the bottom, then we could achieve an effect like this where just the solid center would be rendered and the grayed out area, if you like, would be clipped. So we would only see the portion of the text that was shown within that solid area. We can also animate subchannel properties. So what does that mean? Well, if we look at offset, offset actually has three properties: X, Y, and Z. And yes, I said Z. I've been in the United States too long. So that allows us to animate a particular property on there, as opposed to animating the whole offset. And finally, we can animate values in property sets, which are exactly what they sound like, and I'll cover those in a little bit more detail later. And we can animate effects, so that could be changing the degree of blur on a Gaussian blur effect, for example. I will touch on effects in a later video. So what are the types of animations that are available to us? Well, we have a keyframe animation, and the idea behind this is that we can set a number of control points along a timeline, the timeline being the duration of the animation, and we can specify what value a particular property of a visual should be set to on that particular point in time. We can also leverage easing functions which change how that value changes over time. So to give you an example, if we have a timeline from 0 to 1.0, it's actually interesting to note that control points are normalized. So if I specify 1.0, then that would mean the full duration of the animation. So 0.25 would be a quarter of the way through the animation. So to belabor the point, if an animation is 4 seconds long, 0.25 of the duration of the animation would be 1 second. Then if we take a look at what values we're setting, so what we're saying here is, let's imagine we're animating opacity. After 0.25 of the animation duration, I want to set the opacity value to 0.75. And then after a further 3/4 of the animation, I want to set the opacity value to 1, which would be fully opaque. So you can see how using a linear easing that would transition very smoothly between 0 and 0.75 in quarter of a second or quarter of the animation, and between 0.75 and 1.0 through the remainder of the animation. Implicit animations are a type of animation which are launched by a trigger. So we can predefine a set of animations, so one or more, that they can actually be grouped together, and then leave them registered in the system, and the system can look at a specific property on a visual, say for example an offset, and run these animations when that offset is changed. Finally, we have expression animations, and these are really unlock the power of the composition system, to be honest. You can set up expressions that are evaluated on a per frame basis, and remember the compositor runs at 60 frames per second, so we can achieve some very smooth effects here. And these expressions, they can be something as simple as monitoring a single property on a visual so that we can move another visual, say in parallel, or it can perform a number of algebraic effects, or functions I should say, that allow us to create very complicated expressions. I'm going to show you some simple versions of these later on in this video, but you can also use them to achieve parallax, sticky headers in lists, and so on and so forth. So let's take a look at some keyframe animations. Okay, let's create a blank Universal Windows application. Just call it App 11, that's fine. I'm going to use the latest version of the Creators Update SDK that I have installed. Okay, let's create the UI for our application. I'm going to create a photo gallery style application here just to demonstrate some of the effects that we can achieve with composition animation. So let's put that UI together. So inside here I'm going to have a grid view. Now let's just call that X name gallery. We're going to want to set an item source on this, but I'll come back to that in a moment. We're going to create ourselves a data template. So grid view dot item template, and we're going to create a data template. And inside here, we're going to have a grid. We're going to have its width equal to 400. We're going to have a couple of rows. First row is going to be star sized. Second row is going to have a height of auto, so it's sized to the content that we place in that row. Okay, let's come down outside our row definitions. So what we're going to have inside here is we're going to have an image. So our source, well, we need a source. So if you saw my previous video, you know that I have an image, just enough bikes, that I used for these things. So obviously just enough bikes is dropped into my assets folder, so let's put that in here. Source equals assets. Make sure I don't do a typo on the path. Just enough bikes. Okay, I'm going to set its stretch to be uniform to fill. Have a margin of 8. If I could type. We're going to come back to this in a minute, but for the time being, we're going to close off that element. So we've got our image. And now we're going to have a stack panel. First stack panel is going to be vertical orientation, but it's going to be in grid.row 1, which we know is the second row. And we'll put a margin around this of 8. Inside here, we're going to have some text. And this represents the labels of my gallery image. So we're going to have a style here. We'll just use some built-in styles, static resource, header text block, and we're going to say, let's set the text, my image rocks, and let's create another line which will be our author line, and we'll use the body text style for that one, and throw in my name here, seeing as I created that wonderful photo. Okay, then we'll have some UI elements, just represent interaction points, so some buttons, and we'll make these a horizontal orientation. So let's throw a button in here. We're not going to worry about putting any behaviors into these buttons, but they're going to be here just to create a pseudo UI. So let's put a symbol icon inside here, and we're going to have a symbol We'll do add for this one. And let's create another 3 buttons. Okay, so we've got a basic template created here, but obviously in order to see this template when we run the application, we need to have some items that we're going to leverage on our gallery view. So let's set up the item source property. So item source, and I'm going to use xbind, which allows us to go straight to a property in our code behind, and let's call it my photos. Now, if you were going to create one-way, two-way binding, obviously you'd update this, but as soon as I'm going to create this at the very outset, I don't need to worry, I can use one-time binding. So I'm going to create this property. So I hit F7 and it takes me into my code behind. So now I'm going to create a property in my code behind. So let's create my backing property. Because I'm not actually binding to any of this, I can create a simple integer array called my photos. With my get and my set, and I can assign that to a very simple int array, and let's put 255. So there'll be 255 zeros in the int array, but that's enough to drive my UI. So let's run this. Okay, so here I have my grid view with many instances of my image rocks, and you can see 255 of those. So we have our basic UI laid out, but we don't have any fancy animations or anything like that that we've associated with that. So let's take a look at how we would approach that. So what I want to do with my application is I want to have an effect where when my pointer moves into each one of these cells, my image grows, and then when my pointer leaves, the image shrinks. So how can I do that with composition animation? Funny you should ask, that's what I intend to show. So let's close down the application and let's take a look back at our XAML. So we have our image here, and we have some events that we can handle, which is pointer entered, which will create a event subscription for that. And we'll just use the default name and come back in, and we can say pointer exited. And so we can create that one as well. So now we have some hooks in which we can understand when our pointer's moved in and out of those elements and so on. But now we want to actually interact with this. Well, we're going to use our composition animations for that. So let's see how we can go about approaching that. So we're in our pointer entered. So first thing, let's get hold of our image element. So image element is basically the sender, which is an object. So we're going to cast that to an image, if I could type it. And it's always a good policy to do a guard check in case you've miswired your events or whatever. So we'll just return if it's not an image, but why wouldn't it be? So now we're going to get hold of a compositor. And if you remember from the previous video, this is an object factory that is the gateway into this composition system, and we return back object instances for us for animations, for visuals, and so on and so forth. And the easy shorthand to get to that is on the window current.compositor. Okay, so now we have our compositor. Now we want to get hold of the backing visual of our image. So you remember from the previous video, the backing visual is the outcome of the rendering of the XAML framework as it's been handed off into the compositor. So we can do some things with that. So let's get that backing visual. And we use our good friend ECP, Element Composition Preview, to get element visual. And we're going to pass it the instance of the image that we've got. So that's now our image control. So backing visual is now our visual. Also, you may remember when we want to change offsets or scale in this instance of a particular backend visual, we might want to change our center point. By default, it's up the top left-hand side. We want to move it into the center of our backend visual, so it scales out from the center as opposed from the top left. So let's set that. So center point, and if you remember, this is a vector 3, and so we're going to specify that we want our image dot, oh, this has to be float, so let's cast it to float. So image dot actual width divided by 2.0 float. And we're going to do another float, image dot actual height divided by 2.0 float. And then our Z position is, type in Z, is 0. Okay, so now we've centered our scale that we want to do. Now we could just, if we just wanted to do this manually and immediately, we could say backing visual dot scale equals new vector 3, and we do 1.04 float 1.04. Why 1.04? Well, because I happen to know that that worked well. And that will do our effect for us. Equally, on our pointer exited, I can pretty much copy the same thing. And when our pointer exits, we want to set our value back to 1.0. So if we run this, bang, so it immediately jumps up, but we're not using any animation there, and it's a little bit jarring. So how can we go about introducing some animation into this? Well, that's what I'm going to show you. So we're not going to do this immediate set. Instead, we're going to get ourselves an animation. So let's give it a name, scale. Goodness, as I move between keyboards, my fingers are too big. Scale animation, and we're going to use our good friend the compositor to create a scalar animation. And it's a keyframe animation. If you remember from the introduction, we talk about something where we're going to specify we want to move to a particular value at a particular point in time. So this creates a scalar animation. But we know that scale is actually a vector 3, so we don't want a scalar animation. We want to actually create a vector 3 animation. Good job I caught that now, otherwise I'd have got confused later on. So I've got my scale animation. How long do I want my animation to run for? Well, that's a good question. We don't want it to run too long because it would be too much of a distraction. So we can specify its duration from time span, from milliseconds, and let's do 300 milliseconds. This is also a good time to actually show how many different types of properties exist on a keyframe animation. We can specify delay behavior, which is how long it's going to take before our animation actually comes into effect. We can specify whether we're going to move forward in the animation or back in the animation, whether we're going to do multiple iterations of that animation, and so on and so forth. We're actually going to create a very simple animation, which is going to run once in a forward direction. But you can play around with all of these things. As you can see, there's a lot of properties available for us in these. So anyway, I'm going to create something simple. Let's insert my keyframe. So as you remember, we can specify where in our normalized progression, and 1.0, because it's the highest value in the keyframes that we've specified, will represent the full duration. If I now added, say, a 2.0, then 2.0 would represent the full duration, and 1.0 would represent half the duration. So I tend to leave everything in a range of 0 to 1, so that my head doesn't have to keep recalculating how long everything is, but your mileage may vary on that one. So now I'm going to specify the value that I want it to be set, vector 3, and we're going to specify that we want it to go to 1.04, 1.04, and 0. Now, another thing that we can do with our animations is we can specify an easing function. And an easing function changes how an animation is performed, or a keyframe animation. We want to specify that this moves in a linear fashion from the 0 value to our new value here, or our initial value, I should say. So let's create a easing function. Let's create a linear easing And again, we use our good friend the compositor. Create a linear easing function, and I can take this and add this to the end of my insert keyframe. And so this will use a linear easing from the previous keyframe, which we haven't specified, so that's going to be 0 and the initial value, to our new value. It's going to leverage linear easing. Okay, so that's got that. And then all we need to do is we turn around and say, well, on our backing visual, we want to start an animation, and we want to target the visual scale.property. Sometimes IntelliSense is too useful. And we want to run our scale animation. Now you notice I'm using the name of here. I could just as easily put scale here, and that would have the same effect. But you've seen me type. I'd probably end up with something like that, and then it wouldn't work. So it's far easier for me if I use name of. So that's set up our scale animation. When we enter, we're making it bigger. So let's come and do the same thing down here. And let's reset it back to 1. So now when I enter in, you can see that we have a pleasing, steady animation. And this will be on all of our images. And so that's how we can create a very nice, simple effect using composition animation. Let's take a look at some implicit animations. So what I'd like to do is take this existing gallery application and update it to use implicit animations instead of the animations I was creating manually every time the pointer entered and exited. That will show how we can also use templates to reuse animations. The first thing I'm actually going to do is I'm going to take the contents of this data template and create a new user control. That way I can demonstrate some of the nice life cycle elements around creating a template and reusing them across an item. So I'm going to create a new user control. I'm going to call it gallery item. And then I'm going to copy my XAML for my data template, this grid here. So I take that out and place it as the XAML for my grid. For my user control, I'm going to give a name to my gallery image because I'm going to want to get a reference to that in a moment. Okay, let's drop that in there and then come back to main page. So now I want to make sure that I'm using my gallery image item control. So that's in there. Then I want to take the pointer entered and pointer exited event handlers out of there and put them into the code behind of my user control and add all my references. Compile it, run it. So everything's still functioning even though I have it inside my user control. Okay. So now I want to change my user control. So instead of using these animations I'm creating every time the pointer enters and exits for every single instance of this control, I want to create a single implicit animation that is shared across every instance. So how am I going to go about doing that? Well, let's start looking at the life cycle of my gallery control. As it's going to be an instance is going to be created for every container used in our list, I want to attach my animations when it's being created. So let's take a look at how we're going to approach that. First thing I'm going to do is I'm going to subscribe to the loaded event. So loaded, create that method. Okay. Then once I'm in here, I want to apply some animations. Now let's think about how I want to approach this. Every instance of gallery item is going to have an associated visual. So I want to grab hold of that visual and handle that. If I look at how I approach that, I want to create a member variable that references the backing visual for each gallery item. So let's deal with that first and foremost. I'm going to say, what should we call it? Image backing visual is going to be equal to our good friend element composition preview, get element visual. And if you remember, I actually gave a name to our image in our XAML, gallery image. So let me create a backing field for that. So I've got this value set. So every time I'm loaded, I know that I'm going to get this instance and set that value. So that's great. Now what I want to do is make sure that I set my image backing visual center point appropriately. And I've got code down here that does this already, so I can just copy that up. And we know it's gallery image, not image, so I can grab these. So that sets the center point for our image backing visual. As you remember, we need to do that down below. And then what I want to do is I actually want to set my backing visual implicit animations to something. So there is an implicit animations property. And so let's create a method, create implicit animations. Okay, so good so far. We actually do have a problem though, and that is the fact that our center point may change over time. So we might want to actually monitor the size changed for our item and update the center point. I mentioned that in a previous video, so let's just show how you do that. So let's create a new size changed. And so we're going to do a quick check on here because we can't guarantee the order of some of these events. So we want to do a quick guard and say if this is equal to null, then we don't want to reference it, so just return. Don't do anything at the time being. However, if we do have it, then we want to actually perform the same thing that we have here, which is set our center point based upon its dimension. So that shows you how you can centralize and respond to size change events and reset the center point of your animation. So that was just an easy, nice quick win to show you. Anyway, now we want to talk about creating our implicit animations. I mentioned that we can create these as a template and reuse a single template across every instance of a gallery item. We happen to know that in object-oriented programming, there's a type of variable or a type of operation that we can declare that applies to every instance of something in a class, and that is a static operation. So I can actually make this method static, and that implies that we're going to have a static variable. And that variable will check to see if it has been initialized. So scale implicit animations collection. So if it's not equal to null, i.e. we've already set it up, then we want to return that value. Of course, this value doesn't exist yet, so it's going to be of type implicit animation. So let's quickly create that backing field. So we're going to have a private static scale implicit animation collection. Okay, so now we've defined it. So we know we're definitely going to be returning that. So how do we create one of these implicit animation collections? Well, it's actually very, very similar to what we've done beforehand. So if I come down, I can just grab some of this from our previous manually created animation, and we can do a couple of changes to this. We want our compositor, and window.current.compositor gets hold of that. We don't need to get our backing visual because we've already done that elsewhere, and we actually don't need a backing visual when we're creating our templated animation. We also don't need to worry about setting our center point, and we're certainly not going to worry about this for the time being. So now we're going to create our scale animation. And once again, it is a vector 3 keyframe animation, and our duration is going to be 300 milliseconds. One thing we do need to do when we're specifying an implicit animation is we need to specify our target. And so we're going to use name of, to avoid typos, to specify the target of our animation. For this one, I'm actually going to get rid of our linear easing function. It has a nice effect already built into the scale animation that we're using, so I don't want to have the linear. Instead of inserting a keyframe that has a specific address or a specific value that we're going to be animating to, instead we're going to insert an expression keyframe. Now, the magic of expressions, which I'll go into in the next part of this video, is that they are evaluated every time your animation is processed, every single frame of your animation. And so as we know, the compositor runs at 60 frames per second. So if our animation is running, then this expression is evaluated 60 frames a second. We're actually going to insert in here a magic value, which is this.final value. The way that this will work is when we're actually using an implicit animation, it is triggered by a change to a property. This .final value will be set to what that property has changed to. So instead of applying that property change immediately, the composition system will intercept that change, run this implicit animation for 300 milliseconds, moving from the initial value that it was set to the final value over 300 milliseconds. To be honest, this is the same as writing, if I put 0 in here, it's the same as writing at the 0 frame, start at the initial value, and then at the end of the duration, be at the final value. But this is implicit and we don't actually need to add it in. The next thing is, obviously, we're not going to be starting the animation on our backing visual, as we want the system to start the animation for us. So we need to set up an implicit animation that is monitoring a specific value. So how do we do that? Well, we need to define a implicit animation collection. So we use our good friend the compositor to create one of those and pass us a reference to it. And then what we're going to do is in our animation collection, we're going to add a key, and I can either type scale, or once again, to reduce typos, I can use name of visual.scale. And then I assign our scale animation to this implicit animation collection. Now, obviously, you're getting a good hint here that this can contain more than one animation, and it can be monitoring more than one property. So you can build up a whole library of implicit animations that are attached to an object, just monitoring for different changes to give you different effects. You know, you could say you click on it, you might want to pulse the opacity. So you can do all manner of different things that you can monitor and initiate those animations. But we're just going to stick with our simple scale. So now we've actually created our implicit animation collection, and up here we've actually assigned it. So that's great, but it's not going to do anything right now. The reason it's not going to do anything right now is it's waiting for a change on scale. So we need to work out how we're going to do that. Well, if you recall, we used onPointer entered and onPointer exited to actually initiate some of these. So let's delete the old manual approach and look at how we can apply a change. So onPointer entered, we want to turn around and first of all make sure that we've got our backing visual set. So if our image backing visual is equal to null, let's just return. And then we're going to apply a change. But this becomes very, very simple. Because we have an implicit operation that's monitoring changes to this, if we turn around and say, immediately change 1 point R scale, The implicit animation will actually intercept this and use this new value and inject it into this expression as the final value, and then run this 300 millisecond animation. So this dramatically simplifies how we are launching or triggering these animations. So let's reset this back to 0. And let's run it. And as you can see, we have all of these animations still running exactly as we desired across all of these elements, but now we only have a single template animation defined, and we're using implicit animations that are being triggered just by our mouse entering, as opposed to creating new animations each time. Let's take a look at some expression animations, and we'll also take a deeper dive into property sets. So this time around I already have a UWP app set up and ready to go. We're going to start off by creating a simple UI that we're going to use to demonstrate our expression animations and how we can use property sets. So let's go ahead and create a grid. I'm going to give it a width and a height. Let's give it a background so we can see it. Light grey. And as per normal, I'm going to create some rows. And again, as per normal, my first one's going to be star sized, and my second one's going to be auto sized. Then I'm going to specify a surface in which I'm going to draw a visual. And this time around, I'm just going to put a canvas in, give it a name, call it visual element. Why not? So that's in row 0, and then I'm going to add a slider. And so our slider is going to be used to influence the position of a sprite visual that we're going to draw inside our canvas, or on top of our canvas backing visual, I should say. So let's set up some minimum and maximum values for our slider. So 0, maximum's going to be 359. The more astute among you will think, hey, that looks like it might be associated with degrees. That's foreshadowing of something I'll show you later on. It's in grid row 1. Let's give it a name. Offset slider. Okay, and let's also subscribe to the value changed event. Here's our event handler. We shan't throw an exception. Let's come back to the XAML. I just hit Shift F5, or F7 I should say, which helps me navigate straight back to my XAML. Okay, so there's my basic XAML setup, and you know it looks truly wonderful. You know, we run it up. And here's our app and our slider in all its glory. Okay, so next we want to put a sprite visual into our canvas. So let's have a look at how we're going to do that. So there's nothing we haven't seen before. Loaded event. Create our handler. Delete our exception. Okay, so what are we going to do inside here? Well, as per usual, we're going to want to get hold of our compositor. So window.current.compositor. And as we saw before in a previous video about creating visuals, we're going to create a sprite visual. And we're going to use our good friend the compositor to create sprite visual. We're going to set its brush using the compositor. Creating a color brush, and we're going to use colors. Goodness, I can't type. Colors red. Import our references. Okay, colors red. Let's set some dimensions up for our sprite visual. So the size is going to be a new vector 2, and we'll have it 50 by 50. And we're going to set up its offset. Oh, actually, no. Let's set up its anchor point. So rather than initially anchor points are up the top left-hand side, let's put it in the middle of the sprite visual. Now, what's interesting about this is rather than the center point, which we have to supply an absolute position based upon the dimensions, anchor point itself is normalized so that 1.0 in any of the dimensions indicates the full width or the full height. So it's actually much easier to set the anchor point into the center, because all we do is say new vector 2, 0.5f, 0.5f, and so that's always going to be in the middle. So go figure. I'm sure there's a very good reason for why we're doing that. Anyway, we've created our sprite visual, and now let's think about, okay, how do we want to position this? So if we leave it with its existing offset, it's going to be positioned top left hand side. So let's just add it to our current element, which is set element child visual, and we're adding it to our visual element, and we're adding sprite visual. Okay, so let's run this. So here we have it, and as you can see, because I've set the anchor point to be the middle, then 0, 0 translates to the top left-hand side of the actual grid itself, so we can see it's actually hanging out to the edge there. So, say we want to now move that so that it's positioned, say, vertically in the middle, we would do something like this with the offset. We'd set our sprite visual dot offset is equal to a new vector 3, and because our sprite visual is actually 50 wide, half of that will be 25, so we can actually move it in so that it's left aligns with the left hand edge of the canvas, so we can say 25f. Now in the middle we want it to be a float, and it's going to be the visual element dot actual height divided by 2.0f, and we don't really care about the z index. So now if I run this again, we can see now we have our visual in the middle and aligned to the left hand side. Okay, so now let's say we want to use our slider to change the position of that. So one way we could go about doing this is we could actually directly change the offset of our sprite visual. So if I turn around and make this a member variable and refactor this to be a member, so now we've got sprite visual, so I can access this down here. I could set sprite visual dot offset, and I could take this new vector equals, and E contains the value of our slider, so I could turn around and say plus E dot new value. And now we're complaining because this isn't going to be a float, so we have to do our cast on our value. So we're going to say float. So now if I run this, so now we can see as I move my slider, it moves the object. But this doesn't feel very composition-y. It doesn't feel like we're using anything to do with our animation system, and it seems like there should be something to make this a bit easier for us. So let's see how I would go about replacing this very manual operation with an expression animation. So first and foremost, let's create an expression. So I'm going to create var offset x expression, and I'm going to use our good friend the compositor to create an expression animation. And I can supply as part of the constructor for this an expression. So our expression is going to be 25 plus shared properties dot offset x. Okay, so what we can see first and foremost is obviously this is a string, which means you're going to have to pay very close attention to how you type these things, because if you have an error in there, then you're going to get an exception when you try and run this. Second one is 25. Well, that makes perfect sense. I think we can all work out what's going on there. Plus shared properties dot offset x. So what is this shared properties thing? Well, I've mentioned property sets before, and so this is a reference to a property set that's named shared properties, and then it's looking for a particular value inside that shared properties named offset x. So how do we go about creating that? Well, let's create our shared properties. So var shared properties equals, again, our compositor is our gateway to creating all of the things. We're then going to take our property set and we're going to add to that a scalar value that represents our offset x. So we're going to say offset x, so that gives it a name, and apply an initial value, 0. Okay, that's cool. Then what we need to be able to do is we need to reference our shared properties inside our expression. So if I come down to our offset x expression, I can say set reference parameter. If we actually look at this particular offset, we can see we're setting 25 and we're also setting the height. We're going to disable this right now and we're going to set up our expression animation to run, but note that we're no longer defining the vertical position of our offset. So let's set this up. So we're going to say sprite visual dot start animation. We're going to specify the property name. So we're going to just directly update offset dot x. You may recall me pointing out that we can set sub-channel values of a particular property on a visual. So offset dot x is the sub-channel just applying to x. So we can turn around and say, okay, yes, and now we're going to run our offset x expression. So if we run this, we have our offset x applied, and we can see that our sprite visual aligns with the left-hand side, but it's not positioned vertically because we removed that from our manual setting. So let's reinstate that. So the way we're going to do that is we need to add another value to our property set. We're going to call that value y, but this time we're going to assign it the value that we used in our original offset. So now we've got offset y in there. But now what we're actually going to be doing is we need to update both x and y. So rather than specifying that we're going to be just updating our x value, we're actually going to be updating offset as a whole. So we can rename this to just offset expression. But we also need to change what our expression evaluates to. Right now this is returning a scalar value which we can apply directly to our offset x, but we know offset is in fact a vector 3. So now we need to change our expression to evaluate to a vector 3. So let's see how we do that. So to make this easier, I'm going to put this on multiple lines. There are a number of helper functions and capabilities in expressions. One of them is vector 3, and that means that this expression is going to evaluate to a vector 3. So we've already got an expression in place for our x value. So I'm just going to tab and indent these just to make this a little bit easier to see. But now we need to start adding a value in for our y value. Now our y value is just going to be offset x, offset y rather. So that's pretty simple and straightforward, but it's part of shared properties, so I need to do that prefix. So here's shared properties offset x, or offset y, goodness. And we know that our z value, yes, I still say z, goodness, is set to 0. So now what we've done is create an expression animation that is using the offset x and offset y properties from our property set, and is performing this calculation and applying this value and returning back a vector 3. We've turned around and said that this is applied against the offset value of our sprite visual. So now what we should get is an object that's in the center. Let's run it. So now we can see that our vertical position is correct as well as our horizontal position. But of course, moving the slider is still going to use our manual approach. It isn't updating our properties. So let's come in and have a look at how we can actually change that. Well, fortunately, this becomes very simple for us now that we have our properties, that what we can do is in our onValue changed, instead of this, we can now access shared properties. Shared properties are local. Let me refactor that to be a member variable. I'm going to introduce a field called shared properties. Okay, we have that field up here declared, shared properties. So now I can reference them down in this area here. So I can say shared properties, insert scalar, offset x, and set the value again to the float of our new value. Now I don't need to add 25 because that's already done for us up in this expression. So I can just comment this out and run this. And we have exactly the same behavior. Great, wasn't that an awful lot of work to achieve the same thing? Well, we've only just started to look at the power of expressions. Now let's say we want to do something crazy. Let's run that again. Let's say that on the values through to 100, we want to move that red square to the right. But as soon as we hit greater than 100, we want to take a right turn and we want that square to move down. So in order to achieve that, we'd have to have a whole bunch of different logic around how we were moving this. But this is part of the power that expressions give to us. So if we have a look at our expression here, we want to make some decisions based around the values of offset x as an example. And sure enough, the syntax exists to allow us to do that. We can actually use a ternary expression in place here. So I can turn around and say, okay, let's grab my shared offset and say, is it less than 100? If so, then we're going to evaluate this expression. Otherwise, we want it to just be 100 plus 25, so 125. But we want to turn right, so this would stop it moving to the right across the screen, but won't start it moving down. So how are we going to do that? Well, we can also do a ternary expression down here for the offset y. So let's grab this, let's drop this in, and we want to say greater than or equal to 100. Now, if it's greater than or equal to 100, we want to actually perform a calculation. Otherwise, we want it just to be the existing offset y. So let's add another one in here. So we've got shared, introduce our separator. Okay, so now what do we want to do? Well, we're actually going to start adding to that the value of our shared offset x, but we'll subtract 100 because we're already at 100, so we want to start moving it down, and so we'll subtract 100 so that 101 will add 1 to y, and so on and so forth. So now we've got this expression, so let's run that. So now we're less than 100, so we can see we're moving along, get more than 100, and now we take a right-hand turn. And so this starts to unlock some of the power that we have within these expressions. So we can do a number of different activities here. You know, we could move it forward, back, we could suddenly start scaling it, because we're not constrained to just one animation and to updating one particular property as part of these things, because once we've started this animation, it's always running in the system, evaluating this expression for us. And because it's running in the compositor, it's not impacting the performance of our application. So, okay, I mean, this is a fairly interesting animation, but let's do something a little bit fancier. How about we make the square move in a circle based upon this position? This allows us to see some of the other mathematical functions that are available as part of our expression evaluation. So in order to do this, we're going to need to add another couple of properties to our property set. So let's quickly add a couple of extra properties. So we're going to add radius. So obviously the radius of our circle. So we're going to say 200. And we're also going to say angle. Because what we're now going to do is we're going to use our slider to change the angle of the position of the square as opposed to moving it left and right. We now want to change the offset position so that our red square appears in the center of our UI. So let me take this and quickly copy this value into here and change this to be actual width. And then we need to change our expression. So our expression is going to need to use some mathematical functions, sine and cosine. And so that will allow us to actually move things based upon the angle property. So we don't need our ternary anymore. So we're going to use, let's just delete these. So we're starting off with offset X and offset Y. So as we can see, we have our rectangle in the center. Okay, now we want to introduce our math associated with the position. So we're going to use shared properties dot radius multiplied by the cosine of the conversion from degrees to radians, because our slider goes from 0 to 359. Shared properties. You can see one of the challenges with expressions is you're writing a string, so you don't get any IntelliSense, and you suddenly realize just how used to the compiler and IntelliSense giving you errors around how you're writing these things. Okay, so let's double check. Offset X plus shared properties dot radius multiplied by the cosine of the angle converted to radians. Okay, so now we're going to do a similar thing, but we're going to use the sine function instead. So let's drop that down here. So change that to sine. Okay, so we've changed our expression, but we haven't changed anything else other than adding radius and angle. Let's come down here and change this so that it's changing the angle property of our shared properties to a new value. So let's run this. So now as we do this, our square moves in a circle based upon that expression being evaluated. But I also mentioned that we can do more than one animation as part of this kind of expression-based system and so on. So let's create another animation where we're going to change the orientation of our square so it always is basically erected on a perpendicular to the edge of the circle, so that it'll be rotating as it moves around. So what we're going to do is we're going to create a rotation expression animation. So we're going to use rotate expression, and we're going to use our good friend the compositor to create another expression animation for us. And we're going to make this one very simple. This is going to be shared properties dot angle. Okay, so we need to make sure that we're referencing that. So let's copy that, drop that down here, change this to the rotate expression. Okay, so we've now set up our references, and now it's as simple as starting another animation. This time we're going to be using our rotation angle in degrees. Digress. See, now this is why we should use name of, so let's use name of. Name of visual dot rotation angle in degrees, and we're going to use the rotate expression. So now this is going to be rotating our square, our red square, by the same angle that we're using to move it around the circle. So now if I run this up, we can see that our square now follows the outside of the circle. So I hope that gives you some insight into some of the power of expressions. Okay, here are some resources that I found to be very useful. And that's the end of this video.